Today we're going to look at our introduction to graphing sine and cosine lesson. So the way we're going to start this lesson is I'm asking you to take out your calculator. You're going to type in to your calculator y equals sine x. A couple of things. You want to first make sure that you're in the mode for degree. So click mode on your calculator and make sure it's in degree and not radians, because you're going to go to your calculator and you're going to type in the sine of 0, and you're going to fill in on the table. That would be 0. You're going to type in the sine of 30, and if you did that, you would get 0.5. That number should be recognizable from our 30, 45, 60 chart, and 0 is a quadrantal angle, so that you might also recognize that value from around the unit circle. Sine of 45, when we use the chart, we memorize that to be rad 2 over 2. For the purpose of this activity, you're going to round values to the nearest tenth. So for the sine of 45, if you type that in your calculator and round it to the nearest tenth, you're going to get 0.7. The sine of 60 would be rad 3 over 2, but you're going to round the decimal to 0.9. And by the time you get to the next quadrantal angle, which is 90, the sine goes back to being 1. So I'm just going to highlight the quadrantal angles. Those are the ones you'll probably recognize, as well as the 30, 45, 60. So what I'd like you to do is finish typing these into your calculator, and then you're going to graph plot the points from your table, and we're going to make the sine curve. So just pause the video, finish the table, and then see if you can plot your points. So I'm going to finish my table. Okay, and it should look something like that once you've completed your table. The next thing we're going to do is plot. So you might, if you want to pause the video and just try plotting the points and then maybe start it again. So I'm plotting points at 0, 0. I'm going to just kind of note where 0.7 and 0.9 would be in both the positive and negative direction. Just so I'm not looking for it each time. Okay, so I'm plotting this point at 0.5, then 0.7, then 0.9, then at 90 I'm up at 1, 120 I'm back at 0.9, 0.7, 0.5, 180 I'm back at 0. 210 I'm down at negative 0.5, negative 0.7, negative 0.9, 270 I should be at negative 1, 300 back at negative 0.9, then negative 0.7, negative 0.5 for 330, and back at 0 for 360. So now this is a sine, it's called a sine curve. So you're going to do your best to connect your points with a smooth, like curve. We sometimes even refer to the sine and cosine curves as like a wave. So they're smooth curves. Just make sure you're not like using a ruler and you're just kind of doing your best to connect them. And that's overall the shape that one cycle of the sine curve would make. Okay, now we're going to do the same thing, but we're going to look at the cosine function and what it looks like. So when you take a look for cosine, you're going to do the same thing. You're going to make sure, well, you're in degree mode at this point, so keep yourself in degree mode. And now you're going to type in these values for cosine. So what is the cosine of 0 all the way to the cosine of 360? So please pause the video and then pick up with me once you think that you've got the table. So again, a lot of these values will be familiar. The difference is, again, we're not keeping those exact values since we're trying to plot them on a grid. We are going to take the values and plot them, so we want to have them rounded. And you're going to see very similar values as sine, just at different angles. So cosine is also hitting values of 1 and 0 and 0.5 and negative and positive 0.7 and 0.9, just at different places along 0 to 360. And again, some of these numbers should be recognizable. We know these are our quadrantal angles, so 0, 90, 180, 270, 360. When we graph, we really will be graphing with radians present and not degrees. So I'm just going to remind us here of what our quadrantal angles look like in radians. So 2 pi is equivalent to 360. 3 pi over 2 is 270. Pi is 180. Pi over 2 would be 90. And then 0 degrees, 0 radians would be equivalent there. So we have our cosine table filled out. We are going to plot cosine. Notice cosine starts at 1 when the angle is 0, and then it kind of comes down from there. Oh, so let me also just note where 0.9 and 0.7 would be in both directions. Okay, so cosine is going to come down from there. So it's going to go to 0.9 at 30, 0.7 at 45. Cosine of 60, if you remember from the chart, is 1/2 or 0.5. Cosine of 90 is 0. Now we go beyond 90, so now we're into like quadrant 2 angles. We know cosine is negative in quadrant 2. Now we can see it on the graph. For 120, it's down at negative 0.5. 135, it's down at negative 0.7. 150, it's down at negative 0.9. It's at negative 1 for 180. Now we're going into like quadrant 3 angles. So for 210, cosine is still negative, still negative. By the time it gets to 270, in between quadrants 3 and 4, it's back to 0. And then here are my quadrant 4 angles, and notice that cosine is again positive above the x-axis. And then the cosine of 360 or 2 pi is equal to 1. And again, we're going to make this a smooth curve. And you'll see the overall shape of what a cosine curve looks like. All right, so both sine and cosine are these like nice curve wave-like shapes. Okay, so the next thing that I'm going to have you do is just remember, okay, we're going to graph a sine curve. So what I did here is I plotted what's called a critical point. And you'll see in a minute, if we go back to sine, the points I'm really plotting here, those critical points are the ones that occurred at those quadrantal angles, at the 180, at the 270, and at the 360. So what I'm asking you to do here is just kind of remember the shape here of sine. See if you can sketch a sine curve with the critical points plotted, and then see if you can create your own sine curve and plot those critical points yourself. So pause the video. All right, so again, sine should be smooth, going from that starting point to that maximum, back to that middle point, minimum, back to that middle. And what we're going to start doing here is we're going to be defining these points. Sine and cosine both have maximum points and minimum points, meaning the curves never go, for the examples that we're plotting right now, these curves don't go above 1 or below -1. And then they also have what we call midline points. So the points that are directly in the middle between the max and the min. So if the max is at 1 and the min is at -1, the middle between 1 and -1 would be 0. So the midline, the actual line for it, is y equals 0. That would be the midline of this curve, the x-axis, right? But those 3 points are being plotted on the midline, and then it has one maximum point, one minimum point. So if we try to make our own sine curve, we would start, sine always starts at the midline. It then, at its next critical point, would go to its max height. So maybe I'll put a little 1 over here. Then at the next tick mark here, I'm going to go back to the middle. Then sine would go down to its minimum. Again, I don't have a grid line here, so just do the best you can with the sketch. And then sine ends again at the middle. So it goes from middle to max to middle to min to middle. And that would be one example of a sine cycle. So now let's do the same thing with cosine. I would like you to sketch it with the points plotted and then see if you can make your own. So cosine starts, let's go back for a second just to look again. These are our cosine quadrantal angle points. So cosine of 0 is 0, cosine of 90 is, cosine of 0 is 1. Slow down, Mrs. Carnes. Cosine of 90 is 0. Cosine of 180 is -1. Cosine of 270 is 0. And then cosine of 360 is 1. Cosine has 2 maximums, hits 1 minimum, and hits its midline on its way from its max to its min and its min to its max. So it has 2 midline points for one cycle of cosine. So if we come back down here, I'm going to go from this max to the middle, to the midline, down to the min, back to the midline, up to the max. So again, it has 2 maximums. It kind of starts and ends at its max. It hits the midline. Both of these curves will always hit their midline between their maxes and mins. And then here's its min. So if I were to plot my own, I would make a max somewhere of 1, plot my first starting point. Sine will always start in the middle. Cosine will always start at its max or its min, and we'll talk about when it goes to the min first in a moment. Then it goes to the middle, then it goes to its min, back to the middle, and back to the top. So here is my sketch of one cycle of cosine. Okay. Then, as I was just saying about sine and cosine and where they kind of always start, we want to remember what we know just in general for any function about what does it mean to have a negative in front of the function. And what you might be thinking is that is a reflection, and it's a reflection over the x-axis. So I'm just going to remind myself over here what one regular sine cycle looked like, and that was middle, max, middle, min, middle. So it goes up, then middle, then down, back to middle. Okay, so if sine is going to get reflected over the x-axis, it's still going to start at the middle. So sine will always start at its midline, but instead of going up to its maximum first, it's going to go down to its minimum first, then back to the middle, then it's going to reach its max, then back to the middle. So this is what a reflected sine curve, one cycle of it, would look like. And then if we know that this is also going to be a reflection over the x-axis for cosine, just remind ourselves here, cosine will start at the max, go to the middle, then to the min, then to the middle, then to the max. If this is one cycle of cosine without a reflection, then that would mean if I'm going to reflect it, my starting point, maybe you have it here, should be at the minimum, then the middle, then the max, then the middle, then the min. So from the bottom to the middle to the max to the midline back to the minimum. And that would be an example of a reflected cosine curve. Okay, so I'm going to ask that either on a blank piece of paper or just maybe if you want to go grab a whiteboard, I'm just going to ask maybe 2 more questions. They're not in your notes, but if I was in class today, we would be looking at these on a whiteboard. So the first one I'm going to ask you to think about is, what do you think placing a number in front might do to how we sketch sine? I'm just going to draw myself similar kind of grid. There's my x-axis, my y-axis. I'll put my same 4 tick marks. And just think about it for a minute. Before we were going up to 1 and down to -1. Okay, so if you're thinking, what's going to change about sine? Well, it's still going to start at the middle, but now where is its max? So what this is doing is it's changing the height. This is actually called the amplitude. Oh, that doesn't look like a U. Amplitude, which is the height of both sine and cosine. For this one, obviously, we're looking at sine. So instead of reaching a max of 1 or a min of -1, it's going to stretch it vertically. Now we're going to be able to go a little higher and go a little lower. So now when I go to my next critical point, I'm going to go as high as 2, middle, down to -2, back to the middle. So let's see. So that would be an example of y equals 2 sine x. We're changing our height. So now I want you to try, if I gave you y equals 3, let's do the same thing, 3 cosine x. Try to make this one fit next to it. All right, so just take a moment. Draw yourself an x and y axis. Give yourself those 4 tick marks for the critical points. See what you think. And if you're thinking now we'd be going up to a max of 3 and a min of -3, you would be correct. So cosine always starts at its max. So now it's going to start at 3. It's going to go to the middle. It's going to go down to its min, back to the middle, and end at its max. So it's not changing where it goes as far as max to middle to min to middle. It's just changing what the max and the min are, because the height is being stretched out to a 3 as opposed to a 1. And I'm going to write 2 more and then we'll be done. I want you to give these a try. I'm going to put them both up. So one is y equals -4 sine x. And then we'll do y equals -0.5 cosine x. And again, you're drawing sketches. So my recommendation right now would be pause the video, because I'm going to go right into it and try both of these and then unpause and see if you did it right. Okay, so for my sine, I always start at the middle, but this is changing my height and it's reflecting reflected. So yes, it's going to go as low as -4 and as high as +4, but it's being reflected. So it's going to go to that negative, that minimum first after its starting midline point, then back to the midline, then go to its max of 4, then back to the midline. Something like that. And then for cosine, it's going to just be even smaller in terms of its height. It's going to have a max of 0.5 and a min of -0.5. And it's also being reflected, so it's going to start at that minimum of -0.5, -1/2. Then go to the middle, up to its max of 0.5 or half, back to the middle, back to the min. So minimum, midline, maximum, midline, minimum. Okay, and we will continue on with sine and cosine graphing tomorrow. There is no homework for this lesson. Thank you.